Tonight our speaker is Bill Spitzeri. He's a guy who's been around a while. If you've been with this club for any number of amount of time at all, you know Bill. Bill is a retired mainframe software engineer from Chicago. He's been studying astronomy for about 68 years. He has belonged to several astronomy clubs for 46 years and served in various offices, including president of the Astronomy Club in Chicago. His favorite astronomy activity is teaching astronomy and science to children and the general public. Again, I'm sure Dan can attest that Bill has been a very indispensable member of our outreach team. He currently lives in Katy to be near his 3 grandchildren. Tonight he will be talking on mediocre, almost successful astrophotography. This sounds like it's going to be a hilarious time. So I'm very much looking forward to it. And I will stop babbling now. Bill Spitzeri, take it away.
Okay, thank you, Stephen. I appreciate it. Thanks everybody for letting me speak to you tonight. So now I'm supposed to share my screen. Am I correct?
Yes.
All right, so almost successful astrophotography. You can see the picture of me and my simple setup over there. And as it says on the right, I'm going to be talking about astronomy and astrophotography, and this is a comedy. So don't feel bad about laughing out loud, because I think you'll get some laughs when you see what I tried to do. All right. And I'm hitting the button and it's not scrolling. Let's try this way. Here we go. Here we go. So we all know, I hope you know, you should know by now, that we have tremendous, excellent, talented, successful astrophotographers in the club and in other amateur astronomy clubs too. This is just a small example of the stuff that our astrophotographers have done. Solar system, the sun, deep sky, comets, just tremendous stuff. And one of the main reasons I'm giving this presentation tonight about what I did is so that you appreciate what they are able to do nowadays. Okay, tremendous things. And some of you are those people. You are the fantastic astrophotographers, so I thank you for the great work you've done, and I hope everybody else appreciates it. All right. So, this is a warning. I have never claimed to be a good astrophotographer, ever. Okay? When I got my telescope in 1979, which I still have, I did some obligatory work, the moon, Mars, Jupiter, Saturn. I got Comet Halley in '86. I did Andromeda Galaxy, and I've really done virtually nothing since then, except for the two things that I'll show you here tonight. So I'm not trying to tell you I'm in the same league as those astrophotographers that I just talked about. Okay, so it begins. I'm going to show you two things that I did in the 80s and the 90s, all right? The first one is I learned in the early 80s that there was going to be a total lunar eclipse in July of 1982. That's 42 years ago, okay? And some of you were alive 42 years ago, some of them not. Anyway, 42 years ago, and in case you forgot 1982 or you never knew about it, we had a new president there. Reagan had been president for a year. We had a new spaceship. The space shuttle had been flying for a year. And the big movie was E.T. So that's 1982 in a capsule. All right. So I heard about this total lunar eclipse and I made a plan. And I had absolutely no experience doing this. I don't know what I was thinking. Okay. I didn't even have anybody I could ask about how to do this. No one that I knew had done this. I wanted to capture the lunar eclipse. It's over 5 hours long. So you can't take a picture or two pictures of it to capture it. So I said, you got to make a movie. And by the way, in 1982, we called them movies. Nobody had videos back then, okay? So I'm going to take a movie of the whole lunar eclipse. I'm going to use my C8 Celestron 8-inch telescope, a clock drive to follow the moon. I'm going to piggyback on it an 8mm film movie camera, a big movie camera. Now, in the upper right-hand corner, you see pictures of what the movie reels look like. That's what we call film. For you young folks, Google it. You'll find out what that is. Each one of those reels held only 3 minutes of time of movie. And so I knew that that ain't going to work for a 5-hour event. So it's got to be a time lapse movie, which I, of course, had never done. And I just jumped into it. Okay. So I did some quick math. The camera normally takes movies at frames of 18 frames per second. Okay. But if I wanted to get the 5 hours onto that little reel of film, I've got to expose one movie frame every 15 seconds, not 18 frames per second. Big difference there. Okay. So there's a button on the camera where you push the button, it exposes one frame. And you press the button again and exposes another frame. And I did a quick calculation. It told me I'm going to have to press that button about 70,000 times to get the whole lunar eclipse. So that ain't going to work. So I somehow have to come up with an automated method, which I knew absolutely nothing about. I have no skills in that area. So that's my plan. Simple, right? Yeah, well, you'll see. Anyway, so here is I'm trying to show you what I did. You see a CA telescope. That's not mine, but it's the same, exactly the same kind as I have. And then with my very clever photoshopping, you can see how I put the Minolta 8mm movie camera as it was mounted on top of my C8. Again, the only purpose of the telescope is so that the clock drive follows the moon. The camera on top of it is one taking the pictures. And since it has to be automated, I had to figure out a way to automate it. And I knew nothing about this. So I went to my friend Len Casmer, who is like a real life MacGyver. This guy, mechanical electronics, he did it for a living and he can do anything. So he put together, you see that little picture on the right there, a system that would automate it for me. And here is a close-up of that system. Now, in the upper left, you see a small electronic motor. It's about the size of a plum. It's a small motor. And it's a 1 RPM motor, 1 revolution per minute, much slower than a typical motor. And so that shaft that the orange arrow is pointing at would rotate once per minute. And what's not in the picture is what Len also made was a 4-lobe camshaft, a square piece of wood that went mounted on that shaft, and he rounded off the 4 corners of the square piece of wood. So it was a 4-lobe camshaft, if you know what that is, right? And I really wish I had a picture. I wish I had the presence of mind to take a picture of how this all was mounted on a telescope, but I was concerned with just trying to get the whole thing to work at the time. And I didn't think of doing that picture. But anyway, then the 4 lobes of the cam were positioned such that they would press against that micro switch that the red arrow is pointing to. That's a little bearing, a wheel, which is connected to this. By the way, can you see my cursor? Can anybody tell me?
Yeah, we can
Yes.
see.
Okay, so this tall shaft over here is the switch, the lever that actuates the switch. The cam that would be mounted on this shaft would, once every 15 seconds, because it's 4 lobes on a 1 RPM motor, would press against this wheel, which would push in the lever, which would activate the switch one time. And then this wire was connected to connected directly to the camera, and it would cause the camera to expose 1 frame of film. This was the miracle that Len set up, okay? And the plan was that it would work for about 5.5 hours. And doggone it, it worked for 5.5 hours, 1 frame every 15 seconds. And well, you'll see, you can decide whether you think it worked. So I'm going to show you the movie soon, but this is what you have to watch for. This is the comedy part. Okay, I can't say this stuff without laughing. To spice it up, I thought I had to add music, like we all do with our astrophotography, right? And I knew about and I chose one item from a symphony called "The Planets" by Gustav Holst, which was produced in the, I'd say, 1850 thereabouts. And there's a piece of music on that symphony for each of the known planets at the time. And I chose to use the one called Mercury, the Winged Messenger, because Mercury was the kind of a god of speed, and as you'll see when you do a time lapse movie, things are going fast. And so I thought it was appropriate. I think it worked out okay. So, and then to further Hollywood it up, I added titles and credits, and the titles were created with calligraphy, this fancy script writing done by my brother's wife, Katy. And so I told her what to write in the titles, just with the calligraphy on pieces of cardboard. And then I used my movie camera to take movies of those pieces of cardboard with the titles. And then when that movie was developed, I brought it back. I looked at the film. It was great. I had to literally cut it in pieces. You know how on your computer you do cut and paste? I was really doing cut and paste of paper and film. Okay. So you cut the parts of the film that have the titles, and then you get this special splicing machine with splicing tape, special tape, that so it doesn't block the sprocket holes on the film. So I hope you understand what that is. And so I cut and pasted the titles within the movie, which you will see. Now the movie is really fast, so don't go out for popcorn now. You're going to miss it. Okay. I give credit to Johannes Kepler because of his 3 laws of planetary motion. Without that, of course, we can't have a lunar eclipse. Now you will see when I show you the movie, the Earth's shadow moves in from the left. Okay. You will see occasional image jumps because I just did a lousy job of tracking. I had to set it up when it was still light out, and so no North Star. And so the image will jump once in a while. You'll also see occasional brightness changes because as the moon gets dark, when the Earth's shadow starts to cover it, my super low quality video camera has to be adjusted to open up the lens more, so it can see this dim object, the moon, as the moon's becoming dimmer and dimmer, and you will see the brightness changes. Now, during totality, I could see the moon just fine naked eye, and I could see it just fine through the eyepiece of the telescope, but my low quality movie camera doesn't pick it up, so that it goes completely dark during totality. Okay. And after totality, you start to see the shadow move out, and then clouds roll in, and that's the end of the show. And like I said, this goes by really fast. Now, I told you I've got music on this thing, and the music isn't really loud. So on whatever you're listening to right now, I would suggest, if possible, turn the sound up. I'll try not to talk too loud, but I think the music is a nice part of it. And so, with all of that long introduction, let me get this right here. I will finally show you the movie, which you will see in the credits. It's entitled Eclipse Express because it's so dang fast. So here's the movie. I'm curious, can you hear the music?
Yes.
Okay, that's great. Here we go. Look at that calligraphy, huh? Len built the automated system. See, he did the laws of planetary motion, so he gets credit. And that is the moon. You can see the shadow moving in. So I'm adjusting the camera brightness. So now it's in totality. I could see it, but it doesn't show up on the film. And here the shadow's moving away. I told you it was going to be fast. And then the clouds move in. And that's a street light as I'm zooming back out, thinking that I could see that I'm taking pictures of the moon, but it's the clouds are, and that's somebody's bedroom and a street light. So my plan was to do it again in December, and it was cloudy that night, of course. And that's the name of that tune. Now, as I mentioned to you, Len Casimir was the guy who created my automated system. And at the same time I was making the movie, sort of, he was right next to me with his C8, taking photographs of the entire eclipse, as you can see, using film. On the bottom over there, it says 2415 TechPan film. That's black and white film. And the TechPan, I think, means it detects and photographs many wavelengths of light. So it's good for black and white astrophotography. He was a terrific. He took those pictures that same night. And then when I turned 40 a few years after that, he gave this to me as a gift, which I still have. And so it's a great memory of that evening. So I told you it was going to be fast. I told you it was going to be kind of funny. And there you go. So that's item number one. My next and last item for tonight is from 1994. I think many of you probably know that on July 94, a comet impacted Jupiter, Comet Shoemaker-Levy 9. And even though my results from 1982, was less than stellar, I decided to do something even crazier for the comet impact in 1994. So if you forgot 1994, that's when we had this new thing called the World Wide Web, which we use every once in a while. The Russian Soviet Soyuz space station was setting records in Earth orbit, and we had a strange movie called Forrest Gump. So that was all 1994. There was a few other things happening. That's just a little preview. So here's the three astronomers that discovered that comet. On the left, Gene Shoemaker, his wife, Carolyn, and David Levy. Gene Shoemaker, doggone it, he was one of the best astronomers of the 20th century, in my opinion. And then his wife worked with him a lot, and they were a fantastic team. And Dave Levy, too. The three of them together worked wonderfully. And I'll tell you a little bit more about their work. But anyway, those three discovered the comet in March of 93. I visited them on Palomar Mountain in December of the same year. Okay. They would typically spend a week there every month looking for comets and asteroids. And then the comet hit Jupiter in July of 94. So I visited them right in between the discovery and the impact. And and as I mentioned there on the left, Gene Shoemaker one-handedly invented astrogeology. He had experience with craters and trained Apollo astronauts so they knew what to look for when they went to the moon. He was a great astronomer, great scientist. Anyway, so on the left, you can see a diagram of the orbit of the comet. There's Jupiter, and to the left of Jupiter, you see this single blob above the word night side. That's the comet. And then it is believed that in July of 92, this is before they discovered it, it got too close to Jupiter, and so it broke into pieces. And as you see, it continues in its orbit. They discovered it then in March of 93, when it was already in pieces. Then in July of 93, it was at its furthest distance from Jupiter, now in 21 fragments. And then it continued on its orbit and impacted Jupiter at 125,000 miles an hour, more or less, in July of 94. All right. Oh, and originally, as it says at the top there, they believed that when the comet was in one piece, it was somewhere between 1 and 10 kilometers across. And it, well, most comets, they come from the Oort cloud or the Kuiper belt, and they orbit the sun. This one orbited Jupiter, and it was okay, might have been a comet, or it might have been a captured Trojan asteroid. Since it is no longer with us, we'll never know. In the upper right-hand corner, you see the discovery picture. This is taken with the Palomar 18-inch Schmidt camera, which I'll show you in a little while. And when Carolyn Shoemaker looked through her device that she uses to look at the film, and yes, they did also use film, nothing was digital. She says it looks like a squashed comet. And she referred to it as her string of pearls, which I thought was a really nice poetic name for it. On the bottom on the right, you can see the Hubble view. And sure enough, 21 fragments, they were all between 1/10 of a kilometer and 4 kilometers across. And that's what Hubble saw as it was approaching Jupiter. Here is the Schmidt camera that I mentioned that they used to take the image. Schmidt cameras were designed, the idea came from Bernard Schmidt, 1929. And this particular camera, there's no eyepiece on it, was designed by Russell Porter. You might be familiar with his work. The field of view is larger than the Big Dipper, the bowl of the Big Dipper. Now, that's the whole idea of the Schmidt camera. Very large field of view with pinpoint stars all the way to the edge. Okay. Now, and it got first light on Palomar Mountain. It was the first instrument, shall we say, on Palomar Mountain before the big one that came up in the 40s. It got its first light in 1936. And the first user was Fritz Zwicky, which is a whole nother presentation, if you're familiar with him. Now, so it's a camera. No, there's no eyepiece, but you can see the big white finder scope on the top with an eyepiece. This rectangular area over here is where they insert the film. Okay. This lever with this long extension is how they open the front of the Schmidt camera. And when I was there, David Levy gave me a very detailed demonstration. But anyway, that's basically it. So it's called an 18-inch because the opening is 18-inch, but the primary mirror in the back is 26 inches. The focal length is 26 inches, focal ratio of f2, and the film is a 6-inch circular piece of film, which they processed, developed right there in their observatory. So that's the Schmidt camera. Now there is, as I mentioned, they work a 1 week out of every month. They did that for several years on Palomar Mountain. Gene on the left over there, when I was there, I took these pictures when I visited them. They were so nice and gracious. Give me a complete tour of their observatory, everything that they did. They were just terrific. Let me take pictures and everything. Gene would plan the sessions. What piece of the sky are we going to shoot? And then on any given night, they would shoot many pieces of the sky and then shoot them over again for the purpose of trying to see something that's moving. Okay. In the center, there's Dave Levy with the camera. And then on the right, Carolyn, she's the one who actually searched the film for the moving objects. So she officially gets the official credit for all of the discoveries that this team made. She found her first comet in 1982. She discovered, I believe, a total of 32 comets and 377 asteroids. Okay. There's a whole bunch of stuff flying out there. And these guys were just great at finding stuff. They really knew how to do it. Oh, you can see in the upper right-hand corner there the date when I visited them. Oh yeah, December 9th, 1993. Anyway, so here is a piece of paper that shows, you can see the circle representing the circular frame, which the circular film, which you see a piece of in the upper right-hand corner there. And all of those arrows on the piece of paper with the hash marks on them are moving objects that they have seen in their images. Some of these they discovered, some of these other people discovered, but they had to keep track of everything at any given time and any given date. So they knew if they found something, they knew it was something new. Okay. And not something that someone had seen before. So as you can see, the sky is full of this stuff. I mean, all those moving pieces of rock are how our solar system was created, right? So they kept track of all those things. I found that very interesting. They juggled a whole bunch of information to do their work. So that's what's going to happen, right? So I made a plan. Ha ha ha. Another plan. First, I'm going to point my C8 scope in my driveway at Jupiter on these 2 nights, 18th and the 19th. I'm going to attach a bracket to the scope, custom made by some what do you call it, engineers that made parts for hot rods right down a few blocks from my house. I mean, really super racing machines, right? And they could fabricate anything. So I gave them my measurements. I told them what I needed. They made this bracket. It worked perfectly. There's my household camera. As I mentioned, there was the size of a small loaf of bread. It was a big camera, and it had to be attached to my scope with that bracket that the hot rod guys made. Okay. The camera was then attached by wire to a VHS tape recorder. And if you've had any experience with VHS, you'll know that the quality is not excellent. Okay. And then I would attach the VHS tape recorder to a black and white television that's going to sit on a table next to my telescope. So I could watch all the fantastic occurrences at Jupiter live on the TV set, whose resolution was also horrible. And we were thinking this could be spectacular, huge explosions, or it could be a complete dud. Many smart scientists, smart astronomers said, listen, Jupiter's so darn big. These things are 1 kilometer across or whatever, these pieces. Uh, they'll fall into Jupiter's atmosphere. Jupiter won't even notice. Okay, they'll get sucked up by the atmosphere. Nothing will happen. It'll be a dud, or maybe we'll make a new red spot. Nobody really knew. They were making big bets over at the sports book at Caesar's Palace. I wish I could have been there, as to what was going to happen. So that's my plan. Again, simple, right? I didn't know how to do any of this. I was winging it anyway. So it cracks me up when I just think about it. So to give you a little more idea what's going on, there's a C8 on the left. That's not mine, but a very similar one. And you can see that it had a 90-degree diagonal, which we often use on the Schmidt-Cast telescopes, and it had an eyepiece in it, right? And then at the top there is the bracket that was made by the hot rod guys, made out of aluminum, 90 degrees. It had the, places to put these nuts and bolts, and they came up with the idea of strengthening it with these cables here, wires. And now on the bottom right, you see the back of my C8 with the 90-degree diagonal and an eyepiece in it, right? And then underneath the video camera, you see the bracket that was made by the hot rod guys, okay, attached to the camera mount on top of my C8. And then this, of course, is a different video camera because the one that I used back in '94 is long since went on to the afterlife. And but as you can see, the video camera is pointing into the eyepiece. That's mainly how this crazy system was supposed to work. Okay. I didn't know what I was doing. Anyway, so that was the system. So that means that the image from Jupiter was captured. Well, first of all, it traveled 500 million miles from Jupiter, captured by the scope, reflected off the primary and secondary mirrors. That image was sent through the eyepiece, captured by my extremely low resolution video camera. It takes really good pictures of your kids, okay, but for astrophotography, very low resolution. Then that image was recorded on a VHS tape, horrible quality. Excuse me, no, great quality, great quality. I later, much later, like years later, copied the VHS tape to a DVD. And then later I copied the DVD to my laptop. And then I was able to put the images into the PowerPoint, which you're going to look at. So if I know you guys, there's a lot of guys out there who have tremendous experience with image degradation for various reasons. For instance, like atmospheric degradation. Okay. You can imagine the amount of image degradation that was resulting from all that copying. So I'm making a bunch of excuses for why the images will be the way you'll see they are. Okay. All right. So now the images that scars came from fragments G or H. I'm not exactly sure because there were 21 fragments and they were each given a letter. The impact scar that you'll see in the image, I hope you'll see it, is a black circle in the upper right hand the corner of the disk of Jupiter. Now, these scars are not very clear, which is putting it mildly, to the point where you might think it was just my imagination. But I assure you, as I'm saying here, I was able to see them directly through the eyepiece of my scope, and they were very obvious and much clearer through the eyepiece of my scope as opposed to the VHS and the video camera and everything. Some of these images are very short videos, very short, and some are screenshots from videos. And this was, I assure you, my very first and my very last time that I tried to do digital imagery, 1994. Okay, I know it's the only thing anybody does nowadays, but that was the end of it for me. So let's see. Oh, there was something else I wanted to say. I forgot. Anyway, so screenshots. I have asked around recently when I thought about putting together this presentation, amateur astronomers from every place that I know. 5 different astronomy clubs that I asked about, and I searched the web, I searched YouTube and the web in general, and I couldn't find any amateur astronomer that captured any of the impact scars. Okay, and which really surprised the heck out of me. I thought the web was going to be full of stuff that amateur astronomers had done. I found none, but I will give you an update on that, which I just discovered a few weeks ago, maybe 2-3 weeks ago. I'll give you an update on this situation. Okay, so with that long introduction, oh yeah, I put this in here. I did this when I did this presentation the first time back in the 90s. You know, the solar system was created by pebbles, which came to crash together, became rocks, and the rocks crashed together to became boulders, and they became planetesimals, and they became planets like the one we live on. And that's what happened billions of years ago. And clearly, we now know that's still going on. There's so many rocks, comets, and asteroids flying around that the solar system is still under construction. Okay, so this is something I saw in the grocery store just a few days before the comet impact. A lot of people were feeling the way this guy on the left looks. Okay, this newspaper was at the grocery store. I could not resist it. It's ironically called The Sun. The headline in the upper right says this impact is going to cause the sun to fade. Okay, I don't know why they thought that. And that the crash will cause a new ice age on Earth. And of course, they have a picture to prove that in the lower right-hand corner. There is the skyscrapers of New York, and there's a glacier moving in on it, on New York. So New York was about to be covered up by ice. And if you think that's all fantastic, if you look on the right on the front of the newspaper, a woman won a bingo game, won $5,000, and immediately gave birth. So it was a big news week. Okay, a whole bunch of things in the Sun newspaper. So I'm going to show you the pictures now. Here's picture number, oh, excuse me. This is a video number 1. And as you can see Jupiter. You can see the stripes. It ain't Mars. Okay. And believe it or not, here is the scar, a scar from one of the comets. Now, again, I assure you, they were much more clearer than in the eyepiece than they are here. So this is an extremely short video. I'll play it and you can see what you can see. You might be able to hear the crickets in the background. This is in my driveway. That's the scar. Trust me, it really is. Okay. And here's video number 2. Again, the same scar. I was looking at only one scar all the night. And as you can see, the clarity, the resolution improves now and then a little bit. There you go. It comes and goes, just like when you're observing things through a lot of murky sky. Okay. Here's another video. Oh, by the way, I have to preface this. These are the good images, okay? That's the funny part. This is the best stuff that I could find in all of my images, all right? Here's another short video. Okay. Now, this one's blue because I was told back then in the 80s, and maybe this is common knowledge, maybe still true today, that if you want to see surface features on Jupiter, try a blue filter. And so that I put the blue filter in my eyepiece there for a while. And well, so here's a scar. Is it better? I don't know. Maybe, sort of. Um, Here's another picture. They're all pretty much the same. This again with the filter, and then we're back without the filter. Here's the scar. And if you look, you might be able to tell that I was watching Jupiter for several hours that night, hoping I was going to see something spectacular. And you'll see the scar is moving um, from like the top of the image down towards the lower right, as because we know Jupiter rotates in 10 hours, right? So anything on the surface of Jupiter is going to move quickly. So here's another picture, same kind of thing, same kind of image. Here is a short video that I thought was moderately good. There's the scar, barely visible in the image. Here is another picture. Scar is kind of showing up fairly well. Another one. They're all pretty much the same. I thought this one was kind of a good one. You can kind of see the impact scar very well. That one, well, you can see it. It's not that great. Picture number 9, picture number 10, picture 11. I thought that one was, you can see the scar pretty good in that one. And again, the scar is moving towards the right because of Jupiter's rotation. And there's 12, and that's all of them. Okay. So that was the comedy part. Okay. Now, when you ask the question, which telescopes were pointed at Jupiter at that time, the answer is all of them. Everybody who had anything with a lens in it was pointing it at Jupiter those days. On the upper left, you can see 4 images taken. I don't know with which telescope. Oh, I think this was from Galileo, the spacecraft that was on its way to Jupiter in 1994. And so the green is pointing towards where the impacts were going to occur. I don't think I mentioned this, on the dark side of Jupiter, the side facing away from Earth, so that we can't, it's difficult for us to see anything. But these 4 images, which as it states are 2.3 seconds apart, first there was nothing, 2.3 seconds later you get to see something, and then there's a big boom, and then of course the boom fades after a while. So Jupiter did not just casually swallow up these fragments. There were large explosions that were obviously very visible. Mount Stromolo Observatory in the lower left there saw tremendous fireballs. And to the right of the fireball, you see 3 other scars that had already occurred. These 21 fragments don't hit all at the same time. They hit over a course of a couple of days. And so 1, 2, 3, 4, 5, they would go like a string of pearls, right? And then on the right, you see a Hubble images on July 16th. And obviously you see the edge of Jupiter in 4 different kinds of filters. And at first you see nothing, and then boom, and then as I think it's the fireball then it goes down towards the planet after a while. Again, this is only, let's see, what is this? A few minutes, 12-minute time frame. So the fireball then descends towards the planet. So that's what the Hubble was seeing. So everybody was looking at Jupiter, okay? And these images from Hubble, just the Hubble images alone, caused one of the very first big traffic jams on the internet. 1994, I mean, not a lot of people were on the internet. I, of course, being the leading edge kind of guy, I had a 9600 baud acoustic modem, which, if you know what that is, it's kind of funny by today's standards. And I had Prodigy, AOL, and CompuServe. You may know what those are, but if you're young, you never heard of them. There was a software for getting on the internet. Okay. So this particular scar is from fragment G. The fragment G was 2 miles in diameter, and the fireball that it created was approximately 50,000 degrees Fahrenheit, which translates to about 250 million megatons, and that's just one impact, more energy than all the H-bombs on planet Earth. Okay, so these were big explosions when the fragments hit Jupiter. The plume you see here is about 1,500 miles in diameter, and Earth is only 8,000 miles in diameter. So um, big explosions. And in the plume, was detected in the yellow. You can see all these various elements. Some of these, of course, came from Jupiter's atmosphere, and some of those elements came from the comet fragment. And so, again, we didn't know what was going to happen. This little GIF here, this little short video, is with Heidi Hamill is the one with the glasses in the middle. And they're looking at, and by the way, that's what the monitors looked like in 1994. They're seeing the very first image from Hubble. And of course, they went nuts because it was very spectacular, right? And again, people were betting that it was going to be nothing, and they got excited. So then on that very night, the Planetary Society did a live presentation on PBS, on TV, to, you know, be a live update as to what's going, breaking news, I think we would call that nowadays. On the left, you see Gene and Carolyn Shoemaker and David Levy. They're all anxiously waiting the results. And then Heidi Hamill comes in with the printout of that first image from Hubble. They give them the big news. And as you can see, the three astronomers go nuts because Gene was convinced it was going to be big explosions and you were going to see great stuff. He obviously was right again. He was right a lot. They broke open a bottle of champagne and celebrated all on live TV. It was great. You know, I might have that videotape somewhere. Anyway, maybe I can look that up sometime. But anyway, they broke open the champagne. But Carolyn Shoemaker shed a tear. She was a little bit sad because her string of pearls was going away that she had watched for many months. And she liked her string of pearls. And now it was going on to the hereafter, okay, in the atmosphere of Jupiter. So they were happy that it was exciting, but she had to say goodbye to her string of pearls. And of course, like I said, there were lots of other telescopes looking. There's Sky and Telescope in the October issue. You can see the scars. On the right is one of the pages from that same article with the observatory fireball image, which was fantastic. And then in the middle, you can see some Hubble images where you can see on the right-hand images the aurora at the poles of Jupiter. And apparently, people who examined it were able to tell that the impacts affected the magnetosphere of Jupiter, and so the auroras were affected. I don't know the details of that situation, but there was a lot of great images. In other words, now I mentioned to you no other amateurs took any images. Just a few weeks ago, I found out just by looking on the web, this person that I don't know, Jeffrey Bish, who was one of those sketch artists who would sketch images of the planets. The one on the left is July 14 before the impacts, and in the one on the right, he obviously very expertly sketched one of the impact scars. Not a photographic image, but obviously a very beautiful image that really captured the situation. And in my opinion, I think he knows what he's doing when it comes to sketching planets. And then here's a little video. You can see on the bottom there, there's all the scars from the many impacts after several days, weeks, I don't know exactly how long, where the high winds of Jupiter were just tearing the impact scars apart. But as you can see, the impact scars were significant, really big, and lasted for a long time. So it was a significant event, that's for sure. By the way, when this was discovered, Congress all of a sudden started, for some strange reason, to allocate money to find near Earth objects so that we don't end up as a comet scar, right? Now, then, 3 weeks ago, I found these images made by the amateur astronomer you see on the right. His name is Don Parker. In the 80s and the 90s, I knew of him. Several of the people in our Chicago club went down to where he lives in Coral Gables, Florida. That's south of Miami. That's right on the tip of Florida. He was an anesthesiologist. He died a few years ago, but he really knew what he was doing. I mean, his images of Mars, Jupiter, and Saturn were legendary, and in the magazines, and we would get copies of them at our astronomy club. Again, because the people in our club went down to work with him. He had this in 1994. He's got this 18 or 20-inch Newtonian, and he really knew what he was doing. He was really expert, and he did these images here. Now they don't look great because it's a photograph of black and white images that was published in a newsletter, a paper newsletter. Okay, so they're not great, but look at, man, he merely captured those impact scars for several days. What does that say? The 28th, several days after the things occurred. But it's the best ones from an amateur that I saw. If you got a Hubble telescope, yeah, you can get nice pictures, right? But he, with his expertise, is the only other person that I know, and his maybe are significantly better than mine. Anyway, judge for yourself. So he's the only other guy. So as I mentioned in the beginning, man, when you see these kind of images from our fellow astrophotographers, appreciate them. These people who produce these images are fantastic. Yes, it's many years later, decades later, but they got the scopes, they got the cameras, they got the software, they've got the post-processing. They really got experience. They know what they're doing. And so they produce these fantastic images. So when you see these images, appreciate them, shake their hand when we have in-person meetings, and tell them what a great job they did. Because now look at that picture of Jupiter in the upper right. Imagine if I or anyone, or any of these guys, could have captured images of Jupiter like that right about the time of the comet impact. Holy mackerel. Those would be fantastic. All right. But anyway, that's decades ago. That's mostly what I wanted to tell you. Thank you very much for your time and attention. I hope you're still awake. And I have to be in bed by midnight, but I do have time for questions if you have any.
Thank you very much, Bill. Yeah, if anybody has any questions, you can pop them in the chat or sorry,
I could answer questions because I could answer questions because, as you could see, I'm an expert astrophotographer. Anyway.
Well, and while we wait for anyone else to have a question, I just want to say, Bill, thank you for validating my decision not to bother with that photography until this last year or so, and really get video.
Yeah, well, I was stupid. I didn't know any better, so I gave it a shot, right?
Yeah.
Can I jump in for a second here?
Go for it, Steve.
Bill, surprising that you talked about Shoemaker leaving 9 and everything. In 2 weeks, David Levy is coming to Houston.
Correct.
For the Fort Bend Club meeting, actually 2 weeks from tonight. And that will be on the web, so you can get in that way. He is going to talk about Shoemaker leaving 9, was it 30 years later?
Yes, yes.
So
that's at the Fort Bend Astronomy Club. He's going to be physically there. Yes, correct. I'm going to be there, man. I can't miss it.
Okay. He will be there. So everybody wants to, be on the lookout for announcements from the FBAC Club on how to join with Zoom, and you can get in that way and listen and watch.
Well, I'm no authority. However, Zoom, sure, there's a way you can contact them and do Zoom. But I don't know. I don't think you have to be a member. I could be wrong. I could be wrong. So. But you think I am? You have to be a member to attend the meeting?
No, you do not.
Okay, so there you go. You get to meet David Levy. You see his presentation. Great astronomer.
Yep.
Yeah, Bill. So Matt asked the question. How did you research about the internet?
I'm having a hard time hearing. Say again, please.
Sorry, Bill. Matt asked the question, how did you research without the internet?
Research about the what?
How did you research without the internet back in the day?
What makes you think I researched anything? Okay, I'll tell you. Here's what I do. Every year I receive the Royal Canadian handbook, Observer's Handbook, that told you what was going to happen and when, and it had tons of information. I've been at that point I've been getting it every year for about 20 years. That was a real good source of astronomy information, observing information, future event information. And I did one of the smartest things in my life. I joined an amateur astronomy club, which I strongly recommend to all of you. Okay. And you're talking with people who have got a lot more, everybody there had more experience than me. Okay. And so, like my friend Len Casimir, who set up that automated system for my eclipse video, I had no hope of even thinking how to do that. So you got more people, you got more opinions, you got more experience, and the internet. Oh yeah, there is such a thing. I remember that now. Yeah. I, astronomy magazine, Sky and Telescope magazine. That's it, man. That's it. I was like a caveman with a bone.
All right. Do we have any other questions for Bill?
I'm sorry. Say again. Oh, go ahead.
I was just asking if there were any other questions. All right. I guess we
Okay.
don't have any questions.
All right. Well, I think the vast majority of the people listening in on the call knows how to do this way better than I did back in 1982. That's for sure. Okay. Thanks, everybody. Thanks.
Thank you, Bill. So with that, the meeting. If you want to join us again next month, next month's August meeting will be on September 5th, Thursday at 7 p.m. The meeting. Friday, September 6th at 7 p.m. You can visit our website at astronomyhouston.org for details for that meeting. You'll get the email notification and like you hear everyone. And be sure to visit us on all the socials, and let's see on the screen here. And with that,
I have a question, Stephen.
Okay.
Is this going to go on YouTube?
I believe it is.
I got a friend of mine who wants to see it. Okay, very good. Thank you.
All right. So, so with that, clear skies, everyone. And,
thanks again for everyone's attention. I appreciate it.